We're in 6th grade. Welcome to Investigation 11. We're a few lessons ahead of schedule from getting this one, but we're going to do it anyways. We're talking scale factors in surface area and volume. We've actually been doing this for about 15 lessons, guys. You just get your official lesson on it today. It says this investigation will show the relationship between length, surface area, and volume when we talk three-dimensional shapes. We need these figures that we have right here, and you're supposed to make your own. We don't really need to make and tape these things together, guys. We're just going to do the math ourselves. It says record the measures for each cube. The edge length. Well, guys, how long is an edge? It's 1 centimeter. Okay, so I have 1 centimeter. How long is the edge on 2 centimeters? 2 centimeters. How long is the edge on 3 centimeters? 3 centimeters. How long is the edge on my 4 centimeters? 4. Now I got some major math to do. I'm supposed to figure out the surface area. Okay, so I take 1 times 1, get 1, 6 sides on a cube, so 1 times 6 is 6. I take 2 times 2 is 4. 4 times the 6 faces is 24. I take 3 times 3, I get 9, times 6 is 54. I take 4 times 4 is 16. 16 times 6 is 96. Now I'm going to volume. 1 times 1 times 1 is 1. 2 times 2 is 4 times 2 is 8. 3 times 3 is 9 times 3 again is 27. 4 times 4 is 16, times 4 is 64. It says refer to the table above to answer the following problems comparing cubes. Compare the 2 to the 1. You got it. The edge length of a 2 centimeter is how many times the edge length of the 1 centimeter? How do I get from here to here? Times 2. The surface area is how many times? How do I get from here to here? Times 4. Compare the volume from 1 to 2. How do I get from here to here? Times 8. So I went times 2, times 4, times 8. What did we learn back in lesson, 102, something like that, where we had scale factor? What's our scale factor? We're multiplying by 2. What do we do when we go to the area? 2 squared, because area is squared. That's 4. What do I do with volume? Cube it. 2 cubed is 8. That is what they're going to pound into your head as we work our way through this. Now I'm supposed to compare the 4 and the 2. The edge length from the 2 to the 4. Well, guys, I don't really need to flip this over, but I will. How do we get from 2 to 4? Is times 2. Surface area. How do we get to 24 to 96? Times 4. Probably don't even need to flip it over, but I will to show you. 8 times what gives me 64? 8 times 8. 2, 4, 8. Same thing as the front side. Scale factor, squared, cubed. 3 and 1 now. How'd I get from 1 to 3? Times 3. Guys, I'm not going to flip it over anymore. Surface area, square it. 9. Volume, cube it. 27. Feel free to flip the chart over to see if that's right, but 3 squared cubed. Now we're going, finding the pattern and trying to predict this. How did I get from 2 to 6? 2 times what gives me 6? 2 times 3. Square it. 9. Cube it. 27. It's identical to these guys. 13. Calculate the surface area and the volume of it. Well, okay guys, let's do that. If I have a 6 by 6, I would take 6 times 6, which is 36, times 6 faces. 36 times 6 is 216, but I'll just show the math for you. Is 216. This would be centimeters squared. What's the volume? It's actually the same exact thing, guys. 6 times 6 times 6 is also 216 centimeters cubed. The other way I could have done it, guys, is just gone back to my chart with 3. times it by 9, and times it by 27. And you'll see when you take that times 9 and that times 27, it is your 216 answers. The calculated surface area of a 6 by 6 is how many times the surface area of the 2 by 2? We just answered that one up here, guys. 9. What's the volume? Answered it right here. 27. Find your scale factor. When it's surface area, you square it. When it's volume, you cube it. Next page. It says problems 1 through 6 compared the measure of a 2 and a 1 and of a 4 and a 2. In both sets of comparisons, the scale factor was 4. Now they're just showing you what we did, guys. So you square it, you cube it. In the next one, you had 3. You squared it, you cubed it. The next one is 4. I need to square it. 4 squared is 16. I need to cube it. 4 cubed is 64. Refer to the above description on the scale factor to answer the rest of these questions. Mia calculated the scale factor from a 6 to a 30. From the smaller cube to the larger cube, what's the scale factor? 6 times, I don't know, equals 30. Well, 6 times 5 equals 30. Now let's create our chart that we've been creating. What's the edge length? 5. What's the surface area? That would be 5 squared, which is 25. The next one would be 5 cubed, 125. Bethany noticed that the scale factor relationship for cubes also applies to spheres. She found the approximate diameter of a table tennis ball. Guys, a table tennis ball is a ping pong ball. It's only 1.5 inches, its diameter. A baseball is 3, and a playground ball is 9. Find my multiplier. The volume of a table tennis ball to the volume of a baseball. How did I get from 1.5 to 3? Well, some of you might be able to say 1.5 times 2 equals 3. Because a half times a half, or 2 halves is a whole, and 1 times 2 is 2. So put them together is 3. Now guys, they asked me for volume. This is my scale factor. So I'm back up here. If my scale factor is 2, I cube it and I multiply it by 8. So it says, what's my multiplier? My multiplier is 8. What's the surface area of a baseball to the surface area of a playground ball? Baseball, 3. Playground ball, 9. Sorry, scrolled up a little bit more. Baseball, 3. Playground ball, 9. 3 times scale factor equals 9. 3 times 3 equals 9. I want surface area. Surface area means I square it. So 3 squared is 9. So guys, they're just giving you review. Scale factor, area, square it, volume, cube it. And we just did that again and again and again. Flipping it over. Number 18. The photo lab makes 5 by 7 inch enlargements from 2.5 and 3.5 inch wallet size photos. How'd I get from 2.5 to 5? Times 2. What just happened to my area? Square. 2 squared. 4. Rami wanted to charge the same price per square inch of cheese pizza regardless of the size of the pizza. Since all of Rami's pizzas were the same thickness, he based his pricing on the scale factor for area. If he sells a 10-inch diameter cheese pizza for $10, how much should he charge for a 15-inch diameter cheese pizza? 10 times scale factor equals 15. I would say, how do I get rid of 10? Divide by 10 on the left, divide by 10 on the right. My scale factor, dividing by 10 slides my decimal. My scale factor is 1.5. Now guys, I'm doing area. Area takes that and squares it. So what's 1.5 squared? 2.25. I know 15 squared is 225. Decimal, decimal, 2.25. Now I'm supposed to take $10 and multiply it by 2.25. When I multiply by 10, slides that decimal over. They should charge $22.50. Now many of us would walk into a pizza place and say, a small pizza costs $10 and a large pizza costs $22. My goodness, that's so much more expensive. No, it's exactly perfect, guys. It's exactly what it should be. You are paying the exact amount of pizza. And so we sometimes don't look at that when we look at the pans. And you're like, you got a 10-inch pan and then you got a 15-inch pan. You're like, it's not that much bigger. It really is. Number 20. The Egyptian archaeologists knew that the scale factor relationship for cubes also applies to pyramids. So the archaeologists built a 1/100 scale model of the Great Pyramid. Each edge of the base of the model was 2.3 meters. Well, the edge of the base of the Great Pyramid would measure, obviously, 230 meters. That's my multiplier of 100. From the smaller model to the actual Great Pyramid, what was the scale factor for the length of corresponding edges? Well, guys, already told me. It's times 100. So then the question is, the area of the Great Pyramid is a multiplier of the volume of the model. So how much did the area change? I need to take 100 squared. There's 2 zeros. I need to go double to 4 zeros. It is 10,000 times. Volume, I need to cube it. 100 times 100 times 100. Adds those 2 zeros, add those 2 zeros. It's literally 1,000,000 times bigger in the volume. Here is the chart you completed near the beginning. Should we see how we did? 161, 2824, 354.27, 490. Hey, we got them all right. Yay us. Note that as the size of the cube becomes greater, the surface area and the volume also become much greater at a much faster rate. So this was going up by 1, up by 1, up by 1. This was going up by a lot, right? And even more, growing faster. Note that the volume increases as a faster rate because we're cubing it. This is squaring it. The ratio of surface area to volume changes as the size. So in here, I took this 6 to 1. This is reduced 3 to 1. This is reduced 2 to 1. This is reduced 1.5 to 1. The ratio of surface area to volume affects the size and shape of containers used for packaging products around the world. Sorry, I didn't have that on the thing. I was just reading the bottom of your page. Okay, cruising on. Consider the relationship between surface area and volume as you answer these questions. 64 1 centimeter cubes were arranged to form a one big huge cube. Austin wrapped the large cube with paper and sent the package to Betsy. The volume of the package was 64. What was the surface area? Guys, we already did this. 4 times 4 is 16, and there are 6 sides, so 16 times 6 is 96 centimeters squared. When Betsy received the package, she divided the contents into 8 smaller cubes that were each 8 2 by 2. So 2 times 2 times 2 is 8. Betsy wrapped the 8 cubes, sent them on. What happened to the volume? The volume is still 64. What is the total surface area? Well, guys, we did this. 2 times 2 is 4, times 6 is 24. So the little guy has a surface area of 24, but now I have 8 of them. So I take that times 32, 16 plus 3 is 19. I now have the surface area of 192 centimeters squared. Charlie opened each of these 8 packages and wrapped them as individual 1-inch cubes. Since there are 64 cubes, the volume is still 64. What's the total package area? Well, guys, we have back to the surface area of 6, and we have 64 of them. So I got 64 times 6. That's 24. Carry the 2, carry the 2, and write down the 4. Sorry about that. 36 plus 2 is 38. I'm up to 384 centimeters squared. So what are they showing you? If I go to individual, the surface area goes way up. What happens to the volume? The volume stayed the same. You should recognize this, guys. We did this once. Here comes your extra credit. When did I do that I want the surface area to increase but the volume to stay the same? Science class. So get to your front side and say, in science, cells divide. Now we talked about in science class, why do cells divide? Because I don't want them to be big. I want more surface area that allows more material in. If they got too big, I couldn't get enough nutrients in. So we actually had this picture of these little individual boxes and breaking them apart to try to teach us. Cells go through mitosis to do those things. 24. After a summer picnic with ice in 2 large insulated containers was emptied on the ground to melt. A large block of ice in the form of a 6-inch cube fell out. So we got one big block of ice. That's actually 6 by 6, not 4 by 4. An equal quantity of ice, but in the form of 1-inch cubes, fell scattered out of the other container. So we broke all these as little individuals to melt. Which do you think will melt sooner, the large block of ice or the smaller scattered cubes? Explain your answer. Well, guys, you want the cubes. Now say why. Although what did we learn up here? The volume are I better make that plural. The volumes are the same, but the small cubes will melt sooner than the large block because the small cubes will have greater surface area, is exposed to the warmer surroundings. So guys, if you want a drink and you want your lemonade to get cold on a hot summer day, do I want ice cubes or do I want crushed ice? I want crushed ice. As small as I can, increase the surface area, that'll increase melt, and then we learned that from science class, we're taking the hot out. Allowing the cold to stay. 25. If someone doesn't eat very much, we have a saying. That saying is he or she eats like a bird. However, birds actually must eat large amounts compared to their body weight in order to maintain their body temperature. Since mammals and birds regulate their own body temperature, there is a limit to how small a mammal or a bird can be. So I'm going to compare a hawk and a sparrow in the same environment. Which of the two might eat a greater percentage of its weight in food every day? Now my head says, I bet a hawk eats more. So the correct answer is obviously going to be a sparrow because they're teaching me that sometimes my thinking is wrong. So I'm going to say it's a sparrow. Why? Because the surface area of a sparrow, of a small animal is greater for its volume than it is for a large animal. Small animals work harder to regulate body temperature than a large animal does in the same environment. So, small animals, like sparrows, need to eat a greater percentage of their weight in food than do large animals like hawks. Sorry for this one, I was jumping to sparrow instead of small animals. So guys, they're not saying a sparrow eats more. A hawk eats more, but when we compare to the percentages, when we compare its volume and its surface area, a sparrow actually has to eat more because its volume is smaller. Okay, guys, quick review. We've been working it since we had the lesson on scale factor. Scale factor, squared for area, cubed for volume. That's all Investigation 11 is teaching you, and it's what you need to know. All right, hopefully you got your extra credit on the top. We got those answers taken care of. You have a blessed day.